Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Bono Discovery Center. Today we're going to be looking at technical mathematics analytical geometry topic. And that's the topic that is in paper 2. And we're going to look at the weighting of those topics in paper 2. Now realize that in paper 2, the weightings, the trigonometry will still be 50 plus minus 3. The analytical geometry will be 25 marks plus minus 3. And the Euclidean geometry will be 40 marks plus minus 3. And circles, angles, and angular movement and measurement will be 35 marks plus minus 3. So we're only going to look at the analytical geometry part today. Now, and that's why we need to get marks in this topic, because it's quite an easy topic. You're given the formula, you need to substitute into the formula, know all your formulae in analytical geometry. Now, in the next slide, you'll see we have the objectives of this lesson. Now, we need to apply for any points. Now, the points, we are going to be looking at the points. Remember, analytical geometry, we are working in geometrical figures, but using the algebraic methods. We are applying the algebraic methods here. So we're going to look at the formula to determine the distance between the 2 points. That's one thing that we're going to be looking at. The gradient of the line, that is also what we're going to be looking at. The midpoint of the line and the equation of the line between the 2 points. So mostly on all these things that I've said here, we're going to be using 2 points. So any given 2 points, x1, y1, x2, y2. The next one is determine the equation of the line through 1 point and parallel to the given line. So in other words, we have a point given and we are told that this line is parallel to the other one, and then what must we do there? The other one will be 1 point and perpendicular to a given line. So we still have 1 point, but the line where that point is, it's perpendicular to the other line. We're also going to determine the inclination of the line with the aid of that. So by the end of this lesson, we must be able to do all those with the aid of the formula that is given in there. And from there, where the M is between 0 and 180 degrees. Okay. So remember, the angle that we are going to be looking at is any angle that is between 0 and 180 degrees. No angle, your answers cannot be more than 180 degrees. Right. Just to highlight some formulae on the formula sheet. So if you go to your formula sheet, you need to identify the following formulae. We have got the distance formula, which is d is equals to that formula. Remember, if you start with an x2 here, you must start with a y2 there. So if you start with an x1 here, so that formula can have x1 minus x2 squared, but this side I must also have it as a y1 minus y2 squared. So if I change the x1, change it to x1, then I must also start with the y1 on the other side. The midpoint formula has got a capital letter M there. Please realize it by it's a coordinate. So it's a coordinate. So it's M coordinate x and y. So we're looking for those points. The gradient formula, remember the gradient formula is a small letter m. So in if I need the gradient of, for instance, the gradient of AB, I just write small letter m with an AB as a subscript there. So I'll have y2 minus y1 over x2 minus 1. Similarly, if I start with y1 minus y2, I must add in my denominator have x1 minus x2. Please don't swap them around, because once you swap them around, then you get wrong answers. The next one there is an inclination of the line. So we have that inclination. It's m, which is that value there, which is the gradient. So meaning that the tangent of an angle is equals to the gradient at which that at which we have that angle represented in the line. So if I've got the angles that we're going to be getting by using this formula, it's when we have a line, a straight line that has that angle like that. So in other words, it is the angle between the line and the x-axis. So it's always going to be, if I want to use that formula, then I must have the angle between the line and the x-axis. So I might have an angle like that. So it is the angle between the line and the x-axis. So that is those are the angles that we're going to be getting. Those are the inclination angles that we're going to be looking at. We are having an ellipse that we're also going to be working with. The formula that will always be given to you. So your values will always be like that. So in other words, you're having x squared over a squared plus y squared over b squared equals to 1. So that's the formula for the ellipse. Okay. Right. Again, if I can go back to the gradient formula will also form our equation of the straight line. So the equation of the straight line, if I cross multiply this over 1, if I cross multiply that, so I'm going to have y2 minus y1, it's equals to, so the m here will multiply with that, so m into x2 minus x1. So it's actually the equation of the straight line, the formula for the gradient, so we can have the equation of the straight line, and of which that must also be given to you. Right, so we find with the formula. So now with the activities, starting with the activities. Now in analytical geometry, we have 35 plus minus, it's 35 marks. So we have that mark that we have in there. And then we need to make sure that out of those marks, we get at least, it's 35 marks, then at least I must get 20 marks. Remember, you've got your grade 11 one, and you have your grade 12 analytical geometry. So in analytical geometry, grade 10 and grade 11, those questions, we must get them right. That's why we need to calculate the gradient, the equation of the straight line, the inclination, and we need to also know how to find the midpoint of the line. So all those questions, you'll realize that in each and every question paper, you're going to be asked about the gradient. You're going to be asked about the inclination. You're going to be asked about the distance of the line. So all those questions, we must be able to can get it. Let's look at the first one. The first one says, in the diagram, the triangle RST. So given the triangle RST, here's your triangle RST. You are given the coordinates of R, 4 and 3. You are given the coordinate of S, which is 1 and 0. Given the coordinate of T, which is 5 and negative 4. The angle of inclination with the positive x-axis, that's the angle. That thing there should be theta. Right? So the angle there, it's theta. So can you see that the angle is between the line and the x-axis? So meaning that I'm going to use the formula for that formula, m equals to tan. Now, the first question says, determine the gradient of RS. How do I find the gradient of RS? So you go to your formula sheet, you look for the formula for the gradient. Remember, the formula for the gradient is small letter m, it's equals to y2 minus y1 over x2 minus x1. Please check the formula correctly. We are having issues where when we are marking, we get people who write wrong formula. And from there, they say x2 minus x1 over y2 minus y1, which is an incorrect formula. So we need you to please go to your formula sheet and check it correctly. Now, what does this mean with x2 and y2? Y2, y1, x2, and x1. So I can prefer, if I've got RS, I'm looking for the gradient of RS. So I'll prefer writing it as because I'm looking for the gradient of RS, I'll prefer writing it as the y at R minus the y at S divided by the x at R minus the x at S. So which means my x value here and my y value at R and my x value here and my y value at X. That's what it means. So when I substitute, it becomes much easier. I'll go to R and look for Y. So the Y value at R, it's 3. So I'm going to write a 3. And I'll go to S. My Y value at S is 0. So I'm going to write a 0. Divided by. My X value at R is 4. So I'm going to write a 4. My X value at S will be equals to 1. So I'll get minus a 1. So therefore, I'll get 3 minus 0, which is a 3. Then 4 minus 1, which is a 3. My gradient will be 1. So the gradient of RS will be equals to 1. Okay. And this question is usually 2 marks. So the 1 mark will go for the substitution into the correct formula. 1 mark will go for the final answer. So it's quite an easy thing to do. So from here, you can just take out your calculator and then go there, because that step there will not have any marks. Okay, I hope this is very clear. You must be able to do this type of questions. These are easy, straightforward questions. And in analytical geometry, the first question in analytical geometry, this is the first question in paper 2. In paper 2, first questions in paper 2 deals with analytical geometry. Right. Right. Now, the next question here, wants us to determine the formula for the tangent, which is not there. So I'm going to be putting in there, right? So it's 1.1, 1.2.1. Right. In 1.2.1, the first formula there will be, the first question there will be, write down the formula required to calculate the angle of inclination of a line. So obviously, if I go to my formula sheet, then I check the formula for the inclination. That's a simple formula. It's the formula that I've been talking about, which is m equals to tan of theta. Right. So this is what they're looking for. They want you to just write down the formula. The formula is m equals to tan of theta, and that's all. So you're just going to the formula sheet and copying it as it is. So m equals to tan of theta. And they say, the next question says, hence, meaning that whatever you got there in that question, use it to determine the value of theta. Now, how am I going to determine the value of theta here? So already, the theta in here, it's between the x-axis and the line. Can you see that line here? So it's the x-axis and the line. So there's the angle. So already, which gradient am I going to use? I'm going to use the gradient of that line. Do I know the gradient of that line, the gradient of RS? Yes, I already got it in the first question. So I'm going to say here, the tangent of theta, it's equals to the gradient of RS, of which the gradient of RS is 1. So once I've done that, so I know this is tan theta equals to 1. Now, how am I going to get the angle? So you go to your calculator. Know you love your calculators. Go to your calculator and press shift or second function tan, and you press 1. So the angle that you're going to, the value that you're going to get there will be the angle. And if I've done that, if I do it on my calculator there, answer will be, the theta will be 45 degrees. Okay, So meaning that I am right here, that angle is less than 90, so that angle can be 45 degrees. It's less than 90. Okay, right. Now, and these are some of the questions that you get in an exam. You see, with this one, it was supposed to be 3 marks. Now it's so they've divided that into two, so there will be 1 mark for that. And this one, by substituting it correctly and by giving us the angle, then you get two marks. So it's 3 marks, 3 marks, and you have a calculator, you must be able to do it. Okay. Then the next question here, it's 1.3. It says, then in this one, calculate the length of RT. So with the length, I know I'm going to use the distance, the weight length and the distance there. Right. So now I'm going to the formula sheet. I'm looking for the length of RT. So R is there. T is there. Do I have the coordinates? Yes. So you see the objectives here where that we need to use those two coordinates to determine using the formula to determine the length of the line. So the length of this line here, I can see that length there, very long length there. So I need to find the distance of that. So I'm going to say D equals to, now remember the formula for distance is x2 minus x1. It must have a square. Remember the distance we're using the Pythagoras theorem. Then that's plus y2 minus y1 squared. So now, because I need the distance of RT, I write RT there. So obviously, as I said, I prefer to write this one as x and y, x and y. So I'm going to have x at r, which is going to be 4, minus x at t, which is 5. So it's 4 minus 5 squared, plus y at r, it's 3, and then y at t, it's going to be negative 4. So I'm going to write a negative and a negative 4, then I close the bracket. And that should be squared. Everything must be squared. So I'm going to have, so with me, I prefer calculator, that you put everything in a calculator as it is, so that you don't make silly mistakes, whereby you say 4 minus 5, and then from there you make a mistake. Then from there you write maybe 9 or whatever, or 1. Then from there you have 3 minus into minus 4, you write negative 7 or something. Then you make mistakes. So the easy way to do it will be take your calculator, put everything in there. Put a square root sign, open bracket, 4 minus 5 squared, or close bracket squared, plus inside the square root, 3 negative into negative 4, close bracket squared, and you get an answer. So the answer that you're going to get there will be square root of 50. And the question was in simplified set form. It is very important that you read the instruction, because you might be penalized for that. Because if they say simplified set form, it means your answer at square root of 50 is not in a simplified set form. If you want to find the simplified set form, you go to your calculator and then you just press square root of 50, and the answer that you're going to get there will be 5 root 2. Right. So meaning that the length of that is 5 root 2. Okay, so I have the length of RT, and I think by asking this question, you see these questions are scaffolding. In other words, we know that the next question there will be based in this one that we're having there. Right. Now at 1.4, it says calculate the coordinates of the midpoint of ST. So in other words, we need the midpoint of ST. I'm just going to call it M. So the midpoint of ST. So how am I going to calculate the midpoint of ST? So I'm going to go to the formula sheet. So the formula sheet is the one that has formulae, all the formulae. Remember, in analytical geometry, we are basically working with formulae. So that's why I say this section, we must always get full marks in there. So the coordinates of the midpoint of that. So how do I write midpoint? It's capital letter M. And then I'm going to write down what is my X. Okay, I'm going to write the formula down. X1 plus X2. Because I'm looking for ST, I'll say X at S and then X at T all over 2. The other coordinate will be Y at S plus Y at T over 2. Right. Then from there, I'm going to have my M into. So what is my X at S? So it will be 1 plus X at T, it's 5 all over 2. Then I'll have Y at S is 0. Y at T is negative 4 all over 2. So my answer there will be the midpoint will be 6 over 2, it's 3, minus 4 over 2, it's negative 2. I must go and check if that answer might be correct. So I know that if X is 3, it will be somewhere here. I know somewhere there will be 4. So X is minus 2 will be somewhere there. So I'll have that point here. My point there is going to be 3 and minus 2. All right. So I'll have that as my final answer. Okay. So now you see in that, so when we mark the midpoint, we are only going to mark the answers only. So in other words, 3, we are only going to mark 3 and 2, which is 2 marks. We're going to mark 3 and negative 2. So you can do it because it's quite easy. I can just do it without calculating it. I can just go 1 plus 5 is 6. 6 divided by 2 is 3. 0 minus 4 is minus 4. Divided by 2 it's minus 2. So I can just write the answer only here. Okay. But please, I want you to use, when you're practicing, please use your formula so that you get the correct answer without guessing. All right. Now, 1.5, still on the same question. You see, we're still in the same question. Already we know what is this, the length of this line. We also know what is the coordinate of that point here at M. We already got that as 3 and minus 2. We know that this one was 5 root 2. The length of that line was 5 root 2. Then from there, it says, the question says, complete the statement. And these are statements that we must all know. We must practice. When we're practicing, we understand some of the concepts that we're going to be using in here. If two lines are parallel, then their gradients are equal or they're the same. So a line drawn parallel to RS. So this is RS. So we need a line drawn parallel to passing through the midpoint of ST. So we need another line here that is going to be passing through S, but that line must be parallel to that. Hope you understand it. So we need RS is there, but we need the line passing through the midpoint of that, so which is going to be parallel to that, and that line is exactly parallel to that. So we say, hence, determine the equation of the line parallel to R. Okay, so equation of the line parallel to RS, which is passing through the midpoint of ST. So we need the point we have here. So we need the equation of the line. So remember, the equation of the line is that if the gradient, we know the gradient of RS. The gradient of RS We know it. We got it from the first question there, which is 1. Can you see why isn't it very important that you get the correct answers, because you're still going to use them in other questions. The gradient of RS is 1. So if the gradient of this line RS is 1, then it means the gradient of that line here will also be 1, because they are parallel and they must have the same gradient. So if they are parallel, they have the same gradient. So we're going to then look at which point is on this line. So the point that is on this line, it's 3 and m3 and minus 2. So how do I get the equation of the line? So it means I must have the formula. So my formula will be y minus y1 equals to m into x minus x1. Right. So I then substitute the values. My y1 is going to be minus 2, so it will be negative, negative, which will be plus 2. The gradient is 1. The x value is negative 3. Then I just write down my equation there. So my equation will be y equals to x minus 5. Why? If I take the plus 2 to this side, it will be negative 2. Negative 2 and negative 3 will give us negative 5. And the x value is positive x. So if I look at that line here, it's a line which is a gradient. It's increasing, 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 meaning that the gradient is positive, and the value of the y-intercept, if I extend that line there, the y-intercept can be negative. Can you see how I can see that my answers are correct? If that value of the value of c there was positive, my 5 will be somewhere there. So, but this line will never, ever, ever touch that point there. So that's how I can see that my answers are correct. Okay, that question here was just a warm-up question, and I think it was a very nice question. And I hope and trust that you have grabbed this one, because the questions that I'm going to be doing now are more or less the same questions, but somehow differently again. So now let's look at activity 2. Now in activity 2, in the first one, you are given a triangle. Now here you are given a quadrilateral. Now it is a quadrilateral. See, they've got vertices there of P. So the P is given. The Q is given. The R is given. The S, there's something missing there, which is the M. So we have got M, which is missing here. Now, E is the midpoint. We're already given that this is the midpoint. So nice. If I'm given that there's a midpoint, that's very nice, because then I know how to get the equation, the coordinates of E. If they ask me somewhere. If they ask me the coordinates of E, I'll be able to get them. The first question, can you see? The first question, they repeat themselves. The first question is, determine the gradient of PR. So what do? I go to P, I go to R, and then this is the gradient of this line. Obviously, the gradient of that line, because it's a decreasing line, can you see it's decreasing? Then it will be a negative value. So I already know the sign of my gradient. So it's negative. The only thing that I need to do is to write down now the gradient of PR. I'm not going to write down the formula. Not necessary. Once you get used to writing down the formula, you don't need to write down the formula anymore. But when you're practicing, please do so. But when you go to the exam, you don't need to write down the formula anymore. You just substitute, because that's what we're looking for. So the mark will be for the substitution into the correct formula. Okay, so the gradient of PR, I'm going to write down there. So remember, we start with the y value. It's 2 minus 2. So it's 2 minus into minus 2 divided by the x values is negative 2. You see, I've started with the P, then with the R. So it's 2 minus 6. Answer there is 4 over negative 8. And the answer will be negative 1 over 2. So as I say, from here directly to there, you use a calculator, then the calculator will give you a direct answer, which is negative 1 over 2. Can you see now the gradient of that will be negative 1 over 2. So it's a negative gradient. It's decreasing. So that's why we have it as negative 1 over 2. Now we have got an angle here. Can you see the angle is formed between the x-axis and the line? Okay. Now the second question, okay, I was guessing. The second question there says, same information there, but now we need to find the angle of inclination of PR. You see, PR is this line here. The angle of inclination is this one. That angle is way more than 90 degrees. So it means that I cannot get any angle I cannot get a value which is less than 180, less than 90 degrees. Right. So now what do we do? First things first. Remember the formula? It's tan of theta, it's equals to a gradient. The gradient that we're looking for is the gradient of PR, of which we have already got it in the first question. So the gradient of PR is negative 1 over 2. Now first I must get the angle. The angle that I'm going to get. Now the angle that I'm going to get here. First of all, I take my calculator and then I press shift or second function, then I press tan, then you put in 1 over 2. You don't put negative 1 over 2. I'll explain why. I put 1 over 2. Now, once I put 1 over 2, the angle that I'm going to get is called a reference angle. Right. So my reference angle, if I put 1 over 2, it will be 26.57. Without putting a negative. So now, after I've got that, I call that angle a reference angle. I don't call it theta because it is not theta. So I call it a reference angle. Once I got it as a reference angle, then how am I going to get my angle? I'll use the 180 degrees. So when you're working with analytical geometry, remember the angles are between 0 and 180. So that angle is more than 90, so it must be 180 degrees minus the reference angle. So, which is going to be 180 degrees minus 26.57 degrees. Then the value of that theta will now be 153 degrees, 0.4 degrees. That is the correct answer. So that one, it's not the correct answer, it's a reference angle. So we must always guard against that. So every time you have a negative when I'm working with this type of questions, then I know that I'm going to do. Remember, this formula here, the formula here will only work when we have angles here, the x-axis and the line. That's when we use that formula. If I've got any other angle somewhere there or somewhere there or somewhere there, I cannot use that formula for the tangent. Let's get this clear, okay? So there, when I have an angle somewhere there, then I'll have to use other methods, which is geometry methods, Euclidean geometry methods to get to that angle. Okay, like exterior angle of a triangle and, you know, sum of angles in a triangle. So those are the ones that I can use, or adjacent angles are supplementary, all those. Right, now, the next question is the same question again. So now in this one, they say, because we still have that information, the information is still the same. They say, determine the length of QR. Now remember, we know the gradient of that line PQ, but now the length of QR is this one. I need the length of that line. So for the length of the line, remember the formula. The length is nothing else, the distance. So use the distance formula. So the distance formula for QR, I just write QR is equals to the square root of. So then you just substitute. So now I'm going to start with a 6 here with the r. So I'm going to say 6 minus a 0. I must square this plus. Then I've started with the 6, so I'm going to start with the 6 there. It's negative 2, negative into negative 4. Then the whole thing must be squared. As I said, you have to use a calculator. So you go to your calculator, you punch in as it is, square root of, open bracket, 6 minus 0 squared, as it is. And the answer that you're going to get there will be square root of 40. And then from there, they say leave your answer in a set form. So I can either leave my answer there, but if I want to be smart and show that I can do that, I can then go and do it as 2 root 10 if I want to be smart, but it is not necessary. I can leave my answer there at square root of 40 because they did not say put the word simplified set form. They just say in set form. So please don't go to a calculator and then start pressing square root of 40 and get decimals. Leave your answer in set form. If you want to be smart, you can leave it at 2 root 10, but not as a decimal. Okay, I hope I'm very clear on that. Now, to do that, from here to there, you can use a calculator. Just go square root of square root of 40. The calculator will immediately give you 2 root 10. Okay. Now, the coordinates of E, which is the midpoint of that. So with the midpoint, as I said, I can just write down the answer for the midpoint by looking at the sketch. So what I do is the E is between the point P and Q. So I can start with an X. Minus 4 minus 2. Remember, it's a plus. So it's a plus and a minus. So it will be minus 2 minus 4. So for the X value, so it's minus 2 minus 4. So I'll go minus 2 plus minus 4, which is minus 4, all over 2, which is my first value. And then I'll have 2 minus 2 minus 4, because that's a 4, so it will be that. Or minus 0, sorry. So the X will be minus 0, and that will be like that. So it's a 2 and a 0. So it's 2 minus 2 plus 0. So I'll have that. And then from there, I'll have minus 2 minus 4. So the answer there that I'm going to get will be negative 1 and negative 1. Still, you can go and use your calculator there. So you'll get the same answer. So the E point, now I know it's negative 1 and negative 1. Am I right? So I can see this is negative 1 and that point there can be negative 1. So I am correct. So you can check your answers and see if your coordinates are in the right places. So if I got a positive 1, then it will be somewhere there and it will be incorrect. So please check your answers once you've done the correctness of your answers. All right. Then 2.1.5, we're still on the same question. And then we have, they say the angle, now determine the equation of SR. If SR is parallel to PQ, the equation of SR, where is SR? So we have SR. We need that equation of SR. But it says it's parallel to PQ. So these two lines here are parallel. What do I know about the parallel lines? Their gradients are equal. So the gradient of that line, I know it. The gradient of PQ, I think we got it. It was negative 1 over 2. The gradient of that must also be negative 1 over 2. Why? PQ, did we get a gradient? No, we don't have the gradient of PQ, sorry. So we don't have the gradient of PQ. So now we need to calculate the gradient of PQ first. Now, how am I going to calculate the gradient of PQ? So the gradient of PQ The one that we are having is this one. So the gradient of PQ, how do I get the gradient of PQ? PQ, the gradient of PQ will be 2, negative, negative 4, all over negative 2 minus 0. That is the gradient of PQ. So the gradient of PQ, if I use my calculator, they'll get a negative 3. So the gradient of that line there will be negative 3, which means that the gradient of that line will also be negative 3 because they have the same gradient. So if they've got the same gradient, therefore they are parallel. So now I've got the gradient of SR. I've got a point here that I can use. This point here, I cannot use it because it's got an M. Now I'm going to use my formula y minus. So I'm going to use this point here. So it's y minus 2. So it's y plus 2. It's equals to, the gradient is negative 3, x minus 6. So I'll get y plus 2 equals to negative 3x plus 18, and the y value will be equals to negative 3x plus 16. That is the final answer. If I want to make sure that I'm right, I know this line is going there, it's going there, it's going up there, it's going up there. So somewhere there on the x-axis, it might be 16 there. Okay, so I know I'm correct. So, which means every time, and I see that this line is a decreasing line, it's decreasing, so the gradient is a negative, so I'm correct there. So the 16 will also be correct. Okay. If I got a negative value here, I'll be worried because this value, this line will never come closer to the y-axis. Okay. All right. Now, obviously, if they've given you that one as M, they will like you to also calculate it. Now, how am I going to calculate that part there? How am I going to calculate that value, the value of M? Isn't it that I know the gradient of that line? I know the equation of that line first. So the equation of that line is y equals to negative 3x plus 16. That's the equation of that line. So this point here is on that line. So which means I can substitute this point here into that equation. Alternatively, I can use my gradient because I know what the gradient is. It's minus 3. I could use the gradient. For this one, let me use the equation because I already have it. So the gradient of that line is, so the equation of that line is y equals to negative 3x plus 16. This point M is in the first quadrant, so the M will be positive. It can never be negative. So the y value is M. The x value on that point here is 4 plus 16. So I'll have negative 12 plus 16. The M value will be equals to 4. So my M value is equals to 4. So I can be able to then substitute that value there by 4. My coordinates there will be 4 and 4. Okay. And you can't guess that. If you write that one as 4, you will not get a mark because you must show us how you got the value of 4. Okay, because there's a 4 here. So some learners we know, they will just guess it and say, okay, because there's a 4 here. So let me try my luck and put a 4. You will not get even 1 mark. Please don't try that. Work it out. Okay. Right. Now the next question says, show that this is not D, it's a triangle here. The sign of a triangle. Show that triangle PQR. PQR is a right angle triangle. In other words, show that that angle is 90. And how do I show that an angle is 90? There are 2 ways to do this question. The first one will be, if I want to show that that's a right angle triangle, I can use the gradient. What do I know about the gradient? The gradient of this line of PQ and the gradient of QR, when I multiply them, I must get -1. In other words, the gradient of PQ times the gradient of QR must give us -1. That's when it is perpendicular. And once their lines are perpendicular, it means that they are 90 degrees. So the first thing that I must do there is to get the gradient of PQ. Now the gradient of PQ, I think we already got it in the previous one. So the gradient of PQ, sorry, just quickly go back. Okay, so the gradient of PQ, we already have it. It's the gradient of PQ, we already have it in the last question there, it's -3. Now I need to get the gradient of QR. So the gradient of QR, I must calculate it. So to calculate the gradient of QR, I'll have -4 plus 2 all over 0 minus 6. Calculate that and I'll get I'll get 1, I think it's 1 over 3. 1 over 3. So the gradient of QR is 1 over 3 because it will be -2 over -6, which is 1 over 3. So if I check the gradient of QR, of PQ, and I multiply it by the gradient of QR, what is the answer? -3 multiplied by 1 over 3. The answer will be -1. So I can say, therefore, line PQ is perpendicular to line QR. This line here is going to be perpendicular to that because of their gradient, which simply means that if I've got a 90 degrees there, there's no any other angle in this triangle that can be more than 90. Okay, right? So, which means that this is a PQR is a right-angled triangle. Right-angled triangle. Right. So, to prove this, I've used the gradient. The other way to prove this will be, I'm not going to do it. I'll just quickly explain it so that you can do it on your own. I must get the length of this line. So in other words, I must get the length of line PQ, the distance of PQ, and get the distance of QR, and then also get the distance of PR. Right. If I've got the distances of those, then I must check if the distance of this plus the distance of that squared, distance of this squared plus the distance of that squared, will it give me the distance of that line squared? Okay, that's using the theorem of Pythagoras. Seeing that this one will be almost the longest side here, so you can choose that as the longest side and see if this line, that line squared, will give us that line squared. So that one, I think you can do it. So by using the Pythagoras, will be our alternative method. So I'll just write alternative method. Right? Method. So you're going to use the theorem of Pythagoras by doing that. So you get the distances, then from the lengths of those lines, square PQ, square QR, and see if it's the same as the square of PR. If it is like that, therefore, remember, theorem Pythagoras works in any right angle triangle. Right. Okay. This is a question that everyone must get. This 3 marks is non-negotiable. It's a collectible mark. These are collectible marks. So every question paper, you'll have this question, and please, you have to get this one right. This question, it's quite an easy question. There's absolutely nothing that you must worry about on this question. The Cartesian plane will be given to you. Please make sure that you know how to put points on the Cartesian plane. Once I see x squared over 7, then what I need to do, if that value there does not have a square, so I must put a square root. If that value does not have a square, I must put a square root. Square root of 7. If I go to my calculator and check square root of 7 will be between 2 and 3. Because the square root of 2 is 4, square root of 9 is 3. Okay, so it means it will be between 2 and 3. So if it's between 2 and 3, I can go in there and put a mark in there between 2 and 3. And then from there, I just write square root of 7. On the left and on the right, then I just write square root of 7. This side is negative square root of 7. The square root of 64, it's 8. So I'll go to 8 there and put a value there and put a value there. But then I must mark them. I must go and check. On a Cartesian plane, it is not indicated. I must go and check. I can check 1, 2, 3, 4, 5, 6, 7, 8 equal spaces. And then from there, I can check 1, 2, and then in between 2 and 3, and then I can put that. Once you have done that, then you just connect these points. Connect those points without using a ruler. Then you have your 3 marks. That's as simple as that. The 1 mark will go for the shape. The 1 mark will go for the x-intercept. 1 mark will go for the x-intercept, the y-intercept. So these are 3 marks. So, but if I get it like this and I have a x squared over 3 squared, for instance, or plus y squared over 5 squared, equals to 1. Then obviously I take the numbers without the squares and indicate them on the sketch. Indicate them. So I'll indicate a 3, I'll indicate a 5 there, and then from there I draw my sketch. Okay, that was just an example. Okay, right. So this question, it's quite easy. Please make sure that you really get this question. No one must get 0 on the analytical geometry if there is this question. And it will always be there. Right, the third activity that we're going to do now, it's grade 12 work. So in other words, in circles, in analytical geometry, grade 12, you remember you've done circles. Easy questions also. The first question mostly will be determine the equation of the circle, or determine the radius, or determine the diameter. And you're given the points on the circle. You can see with this first one. On this diagram, A, B, C lie on the circle. They say they lie on the circle. So I already told that these points are on the circle with the center O as the origin. So now the line is drawn to intersect B and C, right? A, it's on the x-axis. So in other words, the y value will be 0. It's indicated on the sketch. And AB is drawn. So the equation of the circle, determine the equation of the circle. So one thing that you need to know with the equation of the circle is that you are using the Pythagoras theorem. So the equation of the circle, you're using the Pythagoras theorem. Okay, so we're using the x squared plus y squared equals to r squared. When you're using it x and y, r is for the radius because we're working with a circle. Now, the x squared, you go to the point that is given and which is on the circle. You see, if this point was given somewhere there, I will not use it. But it's on the circle. I'm already told that B lie on the circle. Right? So the x value is -5. The y value is 12. And that is r squared. I don't have r. I don't have a radius. So the radius squared will be equal to 5 squared is 25. 12 squared is 144. I add them together, I get 169. But I am not done. Because the question was the equation of the circle. So when we're marking this, even now when we're marking in June, the problem is still there. Please, after you got the r squared, write down the equation x squared y plus y squared equals to 169. Do not get the square root of 169. Because if you get a square root of 169, you are getting the radius, unless if you are asked to get the radius. But in this case, it's the equation. So the r squared must remain because the equation is in this form. So the x squared plus y squared equals 169 is the equation of the circle. I'm going to write it there. It's the equation of the circle, the given circle, right? So which means my radius is the line from the center of the circle to the circle. So in this case, if I want the radius, I'll get the square root of 169, which is going to be 13. So from here to there, it's 13. From here to there, it's 13. From there to there, the radius is 13. Remember, I'm not writing negative 13 because I'm writing a radius. And from here to there, it's 13. Okay, so it's a radius. From there to there, it's 13, so it's a radius. Okay, right. The next question says, the numerical value of t. I think I gave out the answer before. Okay, what will be the answer there? So I hope everybody can give us the answer there. From there to there, it's a value of x, so it will be 13 units. So the value of t, I just write t equals to 13, just like that. Okay, so t is 13. So that point here, if the point at point A, it will be 0 and negative 13. I mean, sorry, negative 13 and 0. Because they will be talking to the coordinates. But if I'm talking about the radius will be 13. Okay, right. The equation of the tangent to the circle at B in the form y. You see, the equation of the line in analytical geometry is the thing. So which means we are always going to have the questions on the equation of the line, whether it's in the equation of the line given 2 points or parallel or perpendicular, or this one that we're going to do, which is the tangent. So with the tangent, what do I know about the tangent? So first of all, I'm going to show you the easiest method of doing this, the easiest one. So they say at point B, can you see at point B? So we need what? We need the equation of the tangent. What is a tangent? That line that touches that circle at only one point. That is the tangent. It touches that circle at one point. Okay, if it touches at 2 points, it will be a secant. Okay, right. The equation of the tangent to the circle at B, where the point B is given as what? -5 and 12. They say they want it in this form. Right? Y is equals to. Going to show you the very easy way of doing it. And this formula is not there in the formula sheet, but I want you, my boys and girls, to please write it down somewhere and save it at the back of your head, because we're going to use this formula when they need the equation of the tangent, and it's an easier formula to do. I know one of the formula that we know, it's first we must get the gradient of that line, and then change that gradient to get the gradient of the tangent, and then use the formula to get a point. But I'm going to give you an easy one now. Please write it down. So it will be x multiplied by x1. I know some of your teachers, they love this method. Then there will be plus y multiplied by y1 equals to r squared. I know some of your teachers, they love this method. They love this method because it is quite easy. And they tell their learners, this is x1, this is y1, substitute. X multiplied by -5. Y multiplied by 12. The r squared, I already got it in the first one, it's 169. And that's what they tell the learners to say. From here, then I can just write -5x plus 12y equals to 169. but they want it in this form. So just make y the subject of the formula. So I'm going to get 12y equals to 5x plus 169. Then from there, my y value will be 5 over 12 plus x, then plus 169 all over 12. And I leave my answer like that. That is the easiest way of doing that. The other method, obviously, is to first get the gradient of that one, which is going to be 12 over negative 5. The gradient of the tangent, you know you must turn it upside down and change the sign. So the gradient of that line will be 5 over 12. Can you see the same gradient that we have there? And once you have done that, then you substitute your point here to get the equation of the line. So the equation will still be the same. So you'll have y equals to 5 over 12x plus 169 over 2. Okay. All right. I think we are doing very well. All right. Now, activity 4. So can you see the questions are basically the same? The questions are basically the same. So you realize that they just change the numbers there and there, but what you're going to be using, the methods that we're going to be using will almost be the same. Look at this question here. You're given A, B, C as a triangle and M as a midpoint. So if my midpoint is given, I can get that point. And that's exactly what they're asking you to do. Because the M is given. So what should I do? Write down the formula. Now, remember now the formula for my midpoint will be, I need the y value. So it's y is equals to y1 plus y2 all over 2. Remember, I'm looking for the y only. So I'm going to use the y values only the y values. So my y is going to be 2 because there's the midpoint. My y1 is going to be k and then plus 1 all over 2. So if I cross multiply, I'll get k plus 1 equals to 4 and k will be equals to 3. Am I right for k to be equals to 3? Yes, because k is on the positive side of y. Okay, so now that is quite easy. So remember, if the midpoint is given and you need the other point, so write down the formula like that. If I was looking for x, I'll write x equals to y, x1 plus x2 over 2. Okay, right. And I use the y values only for this one because the k is on the y. Okay, the next one says gradient of AC. AC, I need the gradient of that line. Can you see what is going to happen? They want me to get the length. So these questions are guiding questions. So what is the gradient of AC? So the gradient of AC is going to be 1 minus into minus 1 all divided by 2 minus into minus 2, right? Then the gradient of AC is going to be 2 over 4, and the 2 over 4 is 1 over 2, sorry. 1 over 2. So 1 over 2, the gradient of that, can you see it's increasing, so the gradient is positive. The gradient is positive. Right. Can you see the question of gradient comes back every time? So go and practice that. The size of theta, so already I've got the gradient of that line. So the tangent will be, the gradient of that line was half. I think we've done the half. This is the third time we're doing the half. So I think the half there, the gradient of that line there will be, the angle there will be 26.57, and I can just write it correct to 1 decimal places. They said in degrees. So sometimes they might say in radians. I'm just throwing in that one in there. So they might say in radians. So you must know how to change that to radians. Right. 4.1.4. The equation of the straight line, can you see it comes back again? So there are the same questions in every question paper. How am I going to get the equation of the straight line in that form? So BC, where is BC? BC. So first I must get the gradient. So first I must get the gradient. So the gradient of BC will be, so the gradient of BC will be 2 minus 1 all over negative 1, negative 2, and then I'll get negative 1 over 3. Can you see? This one is a decreasing function. Once I get the gradient of BC, then I can use any of the points here. Okay, I prefer to use the one with the positive values. I hate negative numbers. So I'll say y minus, so minus 1, it's equals to the gradient is 1 over 3, the x, and I'll say minus 2. So once I've done that, I'll have minus 1 over 3x plus 2 over 3 plus 1. So y will be equals to negative 1 over 3x, and that one will be 5 over 3. Okay, so 3 times 1 is 3 plus 2 is 5 over 3. So the minus 1 here, I've taken it that side is a plus 1. I've multiplied this inside the bracket. Then my answer is 1 over 3x. 3. So that will be the gradient of that line. I mean, sorry, the equation of the line. So the equation of that whole line here, so is that. The easy way to do also to get the gradient is to use these 2 points, because remember the k, you substitute, you calculated it. So sometimes you might have made a mistake in calculating the k, and then it will mess up your equation. Eh? So to get the equation that the gradient, you can use this point and that point, because they are collinear. Those 3 points are collinear, meaning that they are on the straight line. Okay, so they are the same. Okay. Right, 4.2, quite a nice question here. They're saying if O is the midpoint, and I know O is 0 and 0, and OM here, you can see MO here, we know MO. Then they say use the analytical geometry methods. Can you see? To show that MO and BA are parallel. What do I know about parallel lines? Their gradients must be the same. So which means the gradient of MO, it's quite easy. It's 2 minus 0 and minus 1 minus 0, which obviously will be negative 2. That it's easy to calculate. Let me get the gradient of BA, of AB. So the gradient of AB must also be minus 2. Can you see what they've done? Yeah, it's easy to do. The gradient of AB, what is the gradient of AB? It's 3 plus 1 over minus 4 plus 2, which is going to be 4 divided by negative 2, and the answer is negative 2. So can you see that the gradient of that is negative 2, the gradient of that is negative 2. So the gradient of MO, it's the same as the gradient of AB, which makes MO to be parallel to BA or AB, doesn't matter. So can you see how to show that, showing them that I know that parallel lines have got same gradient. So if the gradient is the same, it's obvious that MO will be parallel to BA. Okay. The next one, it's more or less the same things. We're still talking to MO, and I can, which is now parallel to that. We have already proved that those two are parallel. Now we want to show that the length of this line here, it's twice, the length of this line here, it's twice that. This one, it's half of this. You see, MO, it's half of this. So first I must calculate the length of MO, the distance, which is going to be negative 1 minus 0 squared plus 2 minus 0 squared. Go to your calculator and just put everything on a calculator. Then the length of that will be square root of 5. Don't write it in decimal, just leave it like that in set form. The length of AB is the distance, which is going to be minus 4 plus 2 squared plus 3 plus 1 squared. If I work that one out, you get the square root of 20. And the square root of 20 will be 2 root 5. Right. So can you see that MO is square root of 5. AB is square root of 2 root 5. Can you see that now MO is half of this. AB is bigger, MO is smaller. So MO, AB there will be twice. AB there will be twice that. So we can work that one out, okay? Because that one, if I divide this one by that, I'll get a half. So if I go MO divided by AB, so I'll get a half because the square root of 5 divided by the square root of that. So that cancels out, we'll get 1 over 2. So can you see, we'll get a half BA, okay? So that is correct. So we can then say, therefore, MO will be equals to half of BA or AB. Okay, so I've proved them because I've got their distances. So to prove that the two sides are equal or the other one is half of the other one, use the distance formula. Okay. All right. In 4.3, the diagram is shown that below, and you can see the question, it's straightforward also. Calculate the length of the diameter. So for us to get a diameter, what should we get first? The radius. So I'm going to go get the radius. So how do I get the radius? So remember, it's x squared plus y squared equals to r squared. I already have the point on the circle. Always use the point on the circle. So it will be minus 3 squared plus 4 squared equals to r squared. So the r squared that I'm going to get is 9 plus 16, which is 25. Then in this case, I'm going to get the r first because I'm not looking for the equation of the circle. I'm looking for the diameter of the circle. So the radius is 5, and you know that the diameter is 2 times the radius. So obviously there will be 2 times 5. My diameter will be 10 units. Okay, so the diameter, which will be the line there from there, this is 5. But if the diameter, it passes through the center of the circle, it's 5. So the whole diameter there will be 10 units. Okay. All right. Easy questions. Prove. You see that question there, here. I know most of us are very afraid of those type of questions. In this one, the answer is already given. So they say it passes through. Prove that this line is a tangent. So the tangent is given. So we are working backward. So which means, what should I do? First, I must get the radius of that. So the gradient of that. So the gradient of that, it's always going to be the y value over the x value if it's from the center, because it's 0, 0. Now, the gradient of that line here will be what? Turn this one upside down, it becomes 3 over 4. Okay, so it's 3 over 4. Now, how am I going to get the tangent? How am I going to get the tangent? So I'm going to use the other method of getting the tangent, which is y minus y1. So my y1 is 4 equals the gradient is 3 over 4. I'm working with the gradient, with the tangent. My x value is x there, and then from there we have a plus 3. All right. Now I'm going to work out what my value of the gradient is. So I'm going to say y is equals to 3 over 4 x plus 9 over 4, 4 over 3, and 3 over 4. So I'm going to get 9 over 4 Then from there, what I'm going to do here, I'm now going to, remember the -4 here, I'm going to add it to this side. Now I'm going to multiply throughout by 4 because my 4 is my LCD. I'm going to say 4 times y is 4y. I think I've got it right here. 4 times 3 over 4, it's 3x. 4 times this is going to be plus 9. 4 times that is going to be 16. So I'm going to have, if I bring everything to my left-hand side, I'm going to have 4y minus 3x. 9 plus 16 is 25, so it's minus 25. And that will be equal to 0, and that's what I have in there. So I've already proved that this will be the tangent because I've already calculated the tangent by using the gradient of the radius and the gradient of the tangent. So that's what they want. So in other words, my conclusion is it is a tangent. That line is a tangent to the circle. Okay, can you see sometimes we have to work backwards? Started at the answer, then from the given you the answer, then from there you must work backward. So that's very important. These are some of the challenging questions that we need to also practice, working backward when the answer is given. See, in functions also, you'll be given answers. Then from there you have to work backwards. You might be given functions and then you have to work backwards to get their x-intercept and y-intercept. So I'm just making an example with it. Okay. Right. Now that question here, this question here, just need to change this value. This value is supposed to be 4 here, not 9 units, 4 units. And the question here was sketch the graph. Sketch the graph. Right. Quite a unfamiliar question in there, but if you read that statement, is really easy to write down the equation. Because first of all, you have to write down the equation. So I want to sketch that graph. First of all, I must write down the equation. So if I write the equation, I know this is an ellipse. So they've already told me that given this ellipse. So I know the equation of the ellipse is x squared over a squared plus y squared over b squared. It's equals to 1. It must always be equals to 1. Now, they said the distance between the x-intercept. So this is the x-intercept. So the distance between the x-intercept is 4. So meaning that the distance between this will be 4, meaning that this unit is 2 units, 2 units, so it's 4. So which means that my point will be here, my other point will be here. This is 4 units. So what do I write there? So it will be 4. The square root of 4 was the distance between the, remember, this is the one that is given there is the distance between the 2 points. So there will be 4. So if I do the square root of 4 will be 2, so that's why I have a 2 and a 2 on the other side. The range is 6.5 and negative 6.5. So it's somewhere there. So my points will be there. So in this case here, it will be 6.5, 6.5. So I can write it as 6.5 squared. Okay, so that's how we're going to do that. So from there, I can just draw my ellipse. Can you see how easy that was? They just wanted you to write down in the form x squared over a plus y squared over b. That's exactly what they wanted you to do. Writing down in the form x squared over 4 and y squared over 6.5, and that is equals to 1. Okay. This is easy, straightforward question. This 3 marks, I just want everybody to get the 3 marks. Okay. All right. Now the next question here is activity 5, which is our last activity that we're going to do for today. Right. So now, if I look at this question, it looks very, 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 very complicated. You know, we've got a circle, We have two lines that are parallel. We have a diameter. We have some kind of a triangle inside the circle. It looks very, very, very complicated, but it's quite very simple. Moreover, in this question, they've given us the equation of the tangent of MN. So you see the tangent MN is given. That equation is given. We're given that this line is parallel to there. What do I know about parallel lines? Their gradients are the same. Gradients are equal. So if I know the gradient of MN, I also know the gradient of PQ. Okay. So obviously, do I know the gradient of MN? If this equation, the gradient of that line, the equation of that line is given, Mn. If I go to the equation, I already know what is the gradient of that line Mn. So the gradient of line Mn, I must just simply write it down. It's a decreasing function, so it is right. So if the gradient of that line is minus 4/3, what will be the gradient of that line here? Because they are parallel. Parallel lines have same gradient. So can you see, I'm taking that information that is given, trying to make sense out of that sketch. If I'm given that point as minus 4/3 on this side, and this line passes through the center of the circle, right? That point there will be the same, but different signs. So if the sign is minus 4 and minus 3, this one here will be 4 and 3. It's just a mirror of the other one. Okay, but the values will still be the same, different signs. Okay, right? So now, and you can see that point here, it's 4 and 3. Obviously, this line here passes through 4. And that point is 4, and that point must be 4. So that's how you can check it. And the other one will be obvious. It's a 3, which is in the other side, on the other side, on the first quadrant, which is positive. So it's 4 and 3. Right. I've just made sense of the sketch before I work my sum out. Okay. The first question will be obvious. Determine the equation of the circle. Already know how to get the equation of the circle. The equation of the circle is the x squared plus y squared equals to r squared using the point on the circle. So I've got point A on the circle, point C on the circle, point B on the circle. But point B does not have the x and the y. Point C, I can use it. Point A, I can use it. So I can have x squared plus y squared equals to r squared. Then substitute any of those. So I prefer point C. Let me use point C and 4 and minus 3. So I'll get 4 squared, put brackets, minus 3 squared equals to r squared. So the r squared will be 16 plus 9, which is 25. The equation of the circle will be x squared plus y squared. Can you see I'm writing the equation of the circle? Right? So the r squared equals to 25 is not the equation of the circle. It is the r squared. So we need to write down the equation in that form. Okay. Simple and straightforward. Now let's look at the next one. Write down the coordinates of B. Oh, I think we already got the coordinates of B here. So the coordinates of B, we said is going to be 4 and 3. So those coordinates, they will be 4 and 3. And they said write down. You see, they did not say determine that. But I think with the gradient of PQ, the gradient of PQ, write down the gradient of PQ. I think we've already did that. The gradient of PQ, and they said write down. Can you see? Well, there's nothing to calculate. Why? It is because the gradient of that line is there on the equation. And the gradient of that line was, I think it was minus 4 over 3. Okay, so the gradient of that line here was minus 4 over 3. And so the gradient of that line will also be minus 4 over 3. So the gradient of that line will always be, they say write it down. Don't work it out. Please write it down. So that's how we do that. So there's nothing to work out on these two questions because we already know. Because in this case, if you try to work it out, obviously if you have got the value of b, you can work out the gradient of that, which is 3 over 4. But the gradient of the tangent will then be the opposite of this, which is 4 over 3 with a negative. So you can still check if it's correct or not. The last part of the question is hence, so meaning that whatever you got here, what did we get? The gradient of that line, minus 4 over 3. They say hence determine the equation of the tangent, the equation of this tangent. See, we know the equation of this tangent, but we don't know the equation of that tangent. The only two things that are the same between these two is the gradient. So already I know the gradient of PQ. The gradient of PQ is minus 4 over 3. I know one point here. The point that I'm going to use is 4 and 3. I don't have any choice here. I only know that point here, 4 and 3. Otherwise, I'll use any other point because if my B is incorrect, therefore the equation of my line will be incorrect. But in this case, I don't have any choice. I must use the one that has been given to me, that I calculated. So the equation is y minus y1 equals to m into x minus x1. Okay, now, then I just substitute quickly. So my y1 is 3. My gradient is negative 4 over 3. The x value, and the x1 is going to be negative 3. So the x value is 4, sorry. All right. Now I must just work it out. There I'll have y equals to negative 4 over 3x. Negative times negative is positive 16 over 3. Bring over the 3, this side shall have a 3. So I'm going to have y is equals to negative 4 over 3x plus 25 over 3. There's the equation of the line. Now, if I'm going to use the point 4 and 3 here, I can still use that method. Do you still remember? We have x times x1 plus y times y1 equals to r squared. So I already have the r squared there, which is 25. So my x1 is going to be 4. My y1 is going to be 3. My r squared is going to be 25. Then I've got 4x plus 3y equals to 25. Remember that then you don't leave it there because the question says in the form y it's equals to. So I'll have 3y equals to, bring over the 4x, so it becomes negative 4x plus 25. And divide everything by 3, then I've got y equals to negative 4 over 3x plus 25 over 3, which is the same answer here. Okay, so you can use any of those two methods. Please, in the exam, we don't want you to write two methods. You write one that you are sure of. Okay, remember, if you write two methods, then you are only going to mark the first one. And you find that the first one is the one that you have made a mistake. The second one was correct. Then you only mark the first one and then you scratch the second one. So please do not take chances in the exam. Just write one method that you know, you have practiced and you understand it, so then you don't have any challenges. Don't write or in the exam. Don't say this or this one. Please, we only mark the first one. Okay, so please go and practice your analytical geometry. It's an easier section. It's the first section in the exam. In any question paper, this will give you confidence, going to the next topic, which is trigonometry. Practice your analytical geometry. Practice with 5 or 6 question papers, and you'll definitely get everything right. With those words, I'll just like to say good luck with your term test and your mock exams that you are writing in your schools. Then please do practice every day. Thank you so much.